Hello students. In our previous videos, we learned why metals and non-metals react with each other. Well, now we know why they do so. Yes, metals and non-metals react to attain octet configuration or stable state configuration of electrons in their valence shell or last orbit. So we can say that to achieve octet configuration, metals either lose their electrons and make their respective positive ions, or take electrons and form the respective negative ions. And the bond which is formed between these two ions due to the attraction force between these oppositely charged ions is called an ionic bond, since it is formed between ions. Let us see some examples of ionic compounds and formation of ionic bond between them. Students, as we can see from the table, sodium atom has 1 electron in its outermost shell, while the chlorine atom has 7 electrons in its outermost shell, and it requires 1 more electron to complete its octet. Accordingly, sodium donates its outermost electron to chlorine, and its previous shell, that is L shell, now becomes the outermost shell, which has 8 electrons. Sodium now gets the configuration like argon, that is 2,8, which is a noble gas, and itself also becomes stable. But students, nucleus of sodium atom still continues to have 11 protons, while the electrons have gone down from 11 to 10. As the number of protons are more as compared to electrons, sodium gets a net positive charge on it. Thus we can say that sodium forms a cation, that is Na plus 1. We can write this as Na donates its electron and becomes Na plus. Now chlorine, which has 7 electrons in its outermost shell, accepts the electron from sodium and completes the octet configuration to become stable. After gaining 1 electron, the total number of electrons in chlorine atom becomes 18. But the number of protons in the nucleus still remains to be 17. Since the number of electron is 1 more than the number of protons, chlorine atom gets a negative charge on it. This gives us a chloride anion, that is Cl- ion. This can be written as chlorine accepts 1 electron and becomes chloride ion. Students, as we have seen that oppositely charged ions, that is positive and negative ions, attract each other. Thus, sodium and chloride ions, being oppositely charged, attract each other and form ionic bond to exist as sodium chloride. This attractive force is often referred to as an electrostatic force also. And the bonding because of this electrostatic force of attraction is called an ionic bond. Students, formation of such ionic bonds can also be represented by one other way called as Lewis dot structure representation. Here, as the name suggests, electrons in valence orbit of an atom are shown using symbols like dots and crosses, while the exchange of electrons, that is give and take of electrons between two atoms, is shown by arrows. For example, in our case of sodium chloride, sodium has electronic configuration of 281, that is, it has 1 valence electron. So write sodium and put 1 dot which represents its 1 valence electron in front of it. Now consider chlorine. Its electronic configuration is 287, so it has 7 valence electron, and represent these electrons by crosses around chlorine atom as shown. Now during reaction, sodium gives 1 electron to 1 chlorine atom. This process of giving electron is represented by arrow starting from sodium going towards chlorine. Now write the product as you are shown. Here sodium has no valence electron as it gave away its valence electron to chlorine. So represent sodium simply as Na with +1 symbol, while chlorine accepted 1 electron and now has 8 electrons. So write chlorine in brackets and negative sign on the top of the bracket. The students, this way of representing is called as Lewis dot structure representation. So this was about formation of ionic bond or electrovalent bond in NaCl, that is sodium chloride. Well, can you think how this ionic bond must be forming in calcium bromide, the other salt? Well, you think about this and we will see you in the next video.